Hey everyone, so now that the preview build of Lattice is available, I thought I would do just a quick demo to show off how the tool works and sort of what features you should look out for if you download it. At some point we'll do a proper tutorial, sort of documentation, all of that, but for now this is just going to be a quick overview. Status update on the project. So Lattice is currently in preview, but we've been using it for a couple months now and it's relatively stable. There's not a lot of major compiler bugs left, and we're just sort of squashing editor issues and things like that. So definitely give it a try. Let me know how it goes. There's not a ton of built-in nodes yet into the package. So as you're writing your own nodes, definitely let me know which ones you find useful, which ones we might be able to add back to the package for everyone else, things like that. Hop in the Discord and let me know how it goes. So yeah, let's move on to a quick demo. So we have a basic game prototype, and one of the things I implemented recently was the ability to kill an enemy, and you spawns a little coin and gives you some gold. So you can see how that works. And this is all implemented in Lattice. Let's take a peek at how we can actually write that script. And I've got the scripts open here, the three that are representing this behavior. And I'll go ahead and delete these for now so we can go ahead and recreate them. So Lattice scripts are kind of like game object scripts. You drag them onto game objects and they get baked down, just like a normal script. So to start, why don't we spawn this coin on just kind of like a debug hotkey. So we'll need a reference to the coin prefab. And we can get that with the prefab reference node. Right, so this is the first kind of weird node that Lattice has that is different than the normal ECS workflow. So if you're familiar with ECS, getting a reference to a prefab to spawn is kind of a pain. You have to go in and make a bunch of authoring components, stitch them together, then write a baker, and then recompile everything. It's just kind of a lot of boilerplate just to get that one reference. But with Lattice, you can just drop this node and select any old prefab you want. In this case, we're going to use the icon pop-up, which is our prefab. And Lattice will go in and bake this under the hood. So we can show that off by taking a look at the player entity here, which is the one that's running this script. And we can see that that entity here is baked directly into it, like you would if you were writing a normal baker. So Lattice is just kind of doing that all for you. And we can also debug nodes in Lattice. So if you right-click and say debug value, it'll show you the output of this node. So the output of this node is an entity, and in this case it's the 663 entity, which you can see is the same one that was baked over here. With our prefab, we can go ahead and spawn this on maybe like when you hit the interact key, I think works. So we'll use a spawn node. And this node's a little more complicated. It takes a couple of inputs. So the one it's complaining about, the required one, is the prefab. So we'll go ahead and stick that in. We can look at the ports for a node by holding control. So we can see that it takes in a Boolean for whether or not to spawn. Makes sense. And then two other optional ports. One for the position of where to spawn it, and an owner. This would be if you wanted to specify like a linked entity group or something in entities. In this case, we don't want this to be owned by something. We want it to be like a free entity that can that's not parented or anything like that. So we'll leave that blank. But we do want a position. So the position we want to set it at, let's just set it at the player's location for now. So to do that, we'll grab a local transform node. So in Lattice, you can access any component on an entity just by dropping its node. So we'll grab local transform, and we can see that we've got a position right here. All right, and we'll call this player position. It's usually good practice to be naming your nodes in Lattice just to keep them all organized, just like you would with code. So call that player position, and this one, let's call this icon prefab. Cool. All right, so the last piece of the puzzle here is we need a Boolean. So when do we want to spawn this? Well, we want to spawn it when the key is pressed. Now we could have a node that would just listen for keys and things like that, but in this case, since this is an existing prototype, there's another component we've already written, which is called character control. This is just kind of our input handler component for characters in the game. And one of these booleans, there's a bunch of booleans on it. You can see all of them right here. But one of them is called interact pressed. So we'll just grab that boolean. So whenever interact is pressed, we'll go ahead and spawn the prefab. So now if we hit E, you can see that it's spawning the prefab. Unfortunately, it's spawning it in the floor, so that's not super useful, but you can see it's doing the gist of the behavior. So let's move on to maybe kind of animating the coin. We can also do that in Lattice. So we'll hop over to the icon pop-up script, and this one's just running on each of the individual coins. So the prefab that we spawned, we can dive into that and take a peek. So it's pretty simple. It's just got an executor, which is running the script, and then a child renderer, which is called quad, and that's just a pretty straightforward renderer. So what we probably want to do is raise up quad over time and maybe give it some spin or something like that. So to do that, let's use another node. We can call this, or this one is called time alive. So this one is actually one of my favorite nodes because it just gets you how long the entity has been alive. And that's a different value potentially for each of these icons. This takes in an entity. So we'll use just like a this reference. It's just this entity. We can rename that and call this coin. This is the time in seconds for how long this coin has been alive. So we can confirm that by debugging it. We can see here, might be a little hard to see on stream, but this is a counter that's just sort of ticking up as the seconds pass. So we want to take this time value and animate the height based on that. So we'll use another node that's called simple animate. This gives us access to an animation curve, and we can plug in the time value here. Let's go ahead and turn that off so it's not so noisy. We will use a curve that looks like this. It's probably pretty good. We'll call this, oops, double click here. Call this height. All right. And so what do we actually want to drive? We want to drive the position of the quad, the sort of child entity. And this is also normally kind of challenging with entities. If you've ever tried to access children in a hierarchy, it's a pain in the butt. You have to go in and again stitch them through some authoring components usually, because you don't want to be traversing the hierarchy at runtime. So Lattice has another fancy node. It's called child entity reference. So this is another bake time node, just like the other prefab one. But instead of getting a prefab, this allows you to bake a reference to a child on a prefab. So in this case, it's using just a text name search, but theoretically, we'll eventually swap this for like an object selector, what have you. But if you give it a name here, this will, you can tell it's running at bake time because it's re-importing the subscene. This will spit out that entity reference. So let's go ahead and spawn a coin, and we can debug this value. So we can see that it grabs us and bakes the entity here for that the quad sub entity. So we want to use this entity and drive its position. So just like we used the local transform node before, we're gonna go ahead and grab another local transform node. This time we're gonna write to it. So we'll write to this entity, and we'll write this position. We can't write a float directly. We'll have to use a make float 3 since height spits out a float, and we can create a float 3 out of it. Call this is really just the position. So we can see that this actually popped up because it's already live, but we can see that it's slowly raising up out of the ground. Nice. And we can adjust this, make this a little maybe give like a little pop maybe or something like this. Come on. Something like that maybe? Let's see. Yeah, look at that. Nice. That's looking pretty good. Why don't we, let's see. We can duplicate this and set the rotation in kind of a similar way. So call this rotation. In this case, we'll want to make rotation instead. Right, and this just allows us to plug in some Euler angles. And we can see that they all updated, but we probably want to make this is, yeah, it's clamping here. And so let's see, we want a linear animation, and go ahead and loop. Let's see. We'll need to, right now it's going to 1, so we probably want to make this, what, 2 pi. Okay. Nice. So now they're all rotating. Let's make that a bit faster. Yeah, it's looking good. So now if we, yeah, that's close to what we want. So maybe the last thing we want to do is we want them to eventually die. And the rough logic here, I guess, would be something like, you know, if it's been longer than a couple seconds, we can go ahead and kill the entity. So we'll use a greater than node and check, is the time alive greater than 2? And so this returns a Boolean, and we can, like all these others, we can debug them. We can see that for all the coins, this is currently true because they're all old. In fact, you can actually debug each of the individual coins if you select them up here. So we want to plug this into a kind of a destroy node, and this is a great example of why it's so nice to have custom nodes. So Lattice is, all of these nodes here are just basic C# functions. In this game specifically, we handle destruction in a special way. We basically tag entities with a tag component and then destroy them at the end of the frame. So I wrote a custom node that hooks into that system, and it's just called mark for destroy. All right, we'll plug that in with that Boolean, and we want to destroy the coin. So goes ahead and wipes them because they're all older. Yeah, so let's dive into some of these nodes to kind of take a peek at how they're implemented. We can start with the simpler one. So simple animate is actually rather simple. So it's just a static function. We can see that it takes an input called an animation curve. That's just your normal Unity animation curve, and a time input, and it just evaluates it. Nothing fancy. This prop attribute allows you to specify that it'll show it in the inspector for you to like select and things like that. We can also see the time alive node up here. Time alive is unique in that this node actually keeps some state. So the accrued seconds is stored in this kind of this ref parameter, which allows basically any node in Lattice can just keep around some state if it needs it, which is actually pretty common and makes it easy to add these kind of more advanced nodes pretty easily. We've got the spawn node down here. This one's a little more complicated. This one actually takes in the entity manager. So Lattice will automatically, if you ask for an entity manager, Lattice will automatically inject that. So you don't have to go stitch that in together. You just add the entity manager in your function, and it'll automatically provide it for you. But the gist of this one is all fairly simple. It's just a bunch of if statements and setting some component data, things like that. Just like you'd write it if you were writing it yourself. Let's see, anything else that's fancy? You can see the make float 3 node here. Just calling the constructor, nothing crazy. And you can expose nodes to Lattice by using this Lattice nodes attribute, which will expose all the static functions in a class. Okay. So let's see. Actually, let's take a look at the mark for destroy node. I think that would be interesting. So can pop this one open. Actually, no, this one just this is pretty similar. Just adds our tag component. The other one I'm going to look at is in the next step. Okay, so we have this spawning and rotating, looking good. So now we want to connect it actually to killing an enemy. So let's grab ourselves this sword. All right, and in this case, we're running these scripts here on the enemy. And this is actually going to be pretty simple, pretty similar to the spawning we did before. We can actually just grab most of these nodes from the character script and paste those in here. And instead of the player position, this is actually now the enemy position. So that's all good, but we'll rename that. And the only thing that's different is we want to spawn it for a different condition. So in this case, we'd like to spawn it when the the enemy dies. So this is the node I wanted to show you. It's called, what do I call it? Die this frame. And this takes also an entity, so use this entity. Call this node. So this node is interesting. Again, it's a custom node that you can just write for your projects. So this one actually just reads to see whether or not it has that marking component on it. But this one's interesting because it's got this extra little lattice phase attribute. So one of the things that you can mark a function with is you can tell it where to run in the frame. So it's pretty common with ECS that you want certain gameplay logic to run at certain points in the frame. And with ECS, you'd use like an update in group attribute. And this is kind of like that for Lattice. So you can say, hey, this node runs in this sort of specific system. And in this case, it's running in the Lattice death handling phase. This is just a entity component system here. So when you mark it with this attribute, Lattice will go ahead and make sure that those nodes only run later in the frame, and so that we have a chance to read this tag component. All right, so if the enemy has died this frame, I will go ahead and spawn the coin. Let's see if that works. Yes, looking good. Okay. Last thing that we might want to do is give you some gold. Like everything else, we're just going to drop another project-specific node. This one I called resources on death, I think. Again, nothing crazy fancy here. If the Boolean died, take in the entity manager, and we're just calling out to some of our own scripting logic. Grabs the inventory buffer and adds to it. So yeah, when it with the Boolean here, whether it has died, I'm going to plug that into that, and we'll say let's add 1 gold. Pretty straightforward. Yep, and you can see every time you kill an enemy, we're getting 1 gold. Honestly, it's all pretty straightforward, and so you can add all sorts of new custom nodes for your project. Sort of the philosophy of Lattice is to have a nice set of simple nodes you can use, but most of the nodes you'll want are going to be project specific. So we're trying not to cover every single case with the standard library, and the expectation is that you as an engineer, or maybe if you have engineers on your team, they can go write the nodes you need for your project, for your custom flavor of ECS or whatever you're using, and then expose those for you to use. And you can start to see also how like this starts to allow you to kind of create higher level behaviors. So this bit that we copied and pasted here, like you could imagine creating a custom node out of this called like spawn coin or something like that, right? And then you could expose this and reuse this in other scripts. So Lattice is kind of inherently composable in that way. And as you work and use it, you'll find that you're constantly sort of bundling up more logic into nodes and things like that. Yeah, so that's pretty much the gist of it. So Lattice is currently in preview. You can play around with it right now. There's a Discord channel that if you want to hop in and chat with us, I'd love to hear what you think. Love to see what nodes you try to make, and yeah, just generally see your use cases. So give it a try. Let me know. Thanks for watching.